Hello and welcome to another MUNSCI physics video. Today we'll explore the topic of motion and we'll begin with understanding the 2D SUVAT equations. Now there are 5 SUVAT equations in physics and they're listed here. What do the variables stand for? The S stands for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. Any of these 5 SUVAT equations can be used to find the desired variable, and it is mainly up to you to choose the easiest and most convenient equation. One important thing to remember is that you must do the vertical and horizontal components of SUVAT separately. Don't mix the vertical components and the horizontal components together, otherwise you'll be going on a wrong course and never find the correct answer. Now we are only focusing on horizontal SUVAT and vertical SUVAT, so this shouldn't be too big of a problem. But later on, when we get to solving parabola equations, this becomes crucial to your success. So I want you to remember this by heart right now. Now that we understand the fundamentals of SUVAT, let's begin with the vertical motion example. Here is the question. A driver of a car traveling at 25 meters per second along a road applies the brakes. The car comes to a stop in 150 meters with a uniform deceleration. Calculate the time the car takes to stop and the deceleration of the car. Let's begin with part A. First of all, we write down what we can already derive from this question. We know that the initial velocity u is 25 meters per second. We know that the final velocity v is 0 meters per second because the car eventually comes to a stop. We know that the displacement s is equal to 150 meters. We don't know anything about the acceleration a, so we just leave it out. Part A wants us to find the time t taken for the car to stop. Now I want you to pause this video and then think which SUVAT equation should we use. Now come back to the video. Because we don't know anything about A, we must choose a SUVAT equation that has t in it but no A. The only one is S equals 1/2 V plus U times t. Now we just rearrange this equation to have t on one side and the rest on the other. Now we just plug in the numbers. T equals, and in the fraction, 2s is on the top, so 2 times 150 meters divided by v plus u, so 25. Now 300 divided by 25 should give us 12 seconds, and this is the answer to this question. For part B, it's asking for the deceleration, so we need to find A. Which SUVAT equation should we use now? To find the A value, we use the SUVAT equation v squared equals u squared plus 2as. Why? Because it's better to use numbers that are directly given in the question. Although we calculated t, we can still make a mistake, so using the SUVAT equation without t is the safest method. Now we just rearrange the equation again to have a on one side and the rest on the others. Plug in the values, and we eventually get a equals negative 2.1 meters per second squared. Why is the acceleration negative? Because the car is slowing down and coming to a stop. I hope this all makes sense to you. Now let's move on to vertical SUVAT. Here is the question. A student drops a stone from rest at the top of a well. She hears the stone splash into the water at the bottom of the well 2.3 seconds after releasing the stone. Ignore the time taken for the sound to reach the student from the bottom of the well. A. Calculate the depth of the well, and B. Calculate the speed at which the stone hits the water surface. Let's start with part A. Same as what we've done before, we write down the values that we know from this question. The initial velocity u is 0. The acceleration a is 9.8, which is the Earth's gravitational force. And the time of the fall t is 2.3 seconds. We need to find the depth of the well, which is the displacement s. Which equation should we use? Because we don't know v, we use the SUVAT equation without v in it. So let's use s equals ut plus 1/2 at squared. Now s is already on one side, so just plug in the values. And eventually we get s equals 26 meters. Moving on to part B, now we need to find the final velocity v. Which equation should we use? Well, we use the equation v equals u plus at, because this one doesn't have s in it. Like I said before, we should not use a SUVAT equation with s in it in this example, because we have just calculated s and we might have gotten it wrong. So the most secure way is to use this SUVAT equation. Plug in the values and we get v equals 24 meters per second. Now that we have covered both the horizontal and vertical SUVAT problems as well as the 5 fundamental SUVAT equations, we are ready to move on to the harder motion questions, a combination of both horizontal and vertical SUVAT, and this is the parabolas. Please stay tuned to MÜNSCI's future videos where I will be explaining how to easily solve parabola questions.